Does the energy content in this packet of tuna actually make sense? Let's use our knowledge that we learned in VCE chemistry to find out. The first thing we need to know is where this energy is coming from. It's coming from three main molecules. It's coming from the protein, the fat, and the carbohydrates in this. In our VCE chemistry data booklet, we've got the energy content for these three types of molecules. So let's get a piece of paper and a pen and work this thing out. Protein, fats, and carbs. My protein per 100 grams on my can is 26.0. My fats is 9.9, and I've got basically 0 carbohydrates in my tuna here. Now, using my chemistry data booklet, I know that proteins have an energy content of 17 kilojoules per gram. So therefore, I can work out the energy content of these 26 grams of protein is going to be around about 440 kilojoules. And then my fats is 37 kilojoules per gram. Again, looking at my data booklet, I can see that the energy content from my fats is going to be 366.3 kilojoules. And because I've got no carbs here at all, I'm going to get no energy released from any carbs because there's none in here. Now, if I add these together, I'm going to get a total energy content of 808.3 kilojoules per 100 grams of my actual tuna here. So let's go compare that to what it actually says on the packet. So my packet says there's 809 kilojoules per 100 grams of tuna. My calculations came out at 808.3. So it's pretty reasonable what they're actually trying to state here. Now, even though our calculations are correct and we can see the fact that there's about 809 kilojoules per 100 grams of tuna, our bodies are not actually going to access all of that energy. The main reason for that is the large component of this tuna is protein, and we only access the energy in protein as a last resort. The vast majority of this protein is going to be used for growth and repair and building muscle and things like that in the body, and not for releasing this energy.